CPD facility is provided for IFE members to enable individuals to tailor their CPD portfolio using a blend of sources. IFE is continuing to build an ever-growing range of CPD modules covering a variety of contemporary topic areas. Each module is around 15 to 20 minutes in length and can be viewed as often and whenever individual members wish to do so. IFE-produced CPD modules are produced by international headquarters staff with the content provided by members who are experts in their field, including, for example, the chairs of IFE Special Interest Groups, or SIGs, and members of the Technical Strategic Advisory Group, TSAG. IFE-produced CPD modules have clear learning outcomes, and these can be used to evidence CPD. These CPD sources and more are available through our online CPD hub in the members portal. Please visit regularly to see new additions to the range of modules and other CPD sources.
I think we're good to go.
Good to go? Okay,
Yeah.
Excellent. Then I will crack on. Bear with me. All right, let's do it. So, afternoon, everyone. Thank you so much for dialing into this afternoon's webinar from the IFE Yorkshire and Humberside branch. Apologies, I'm a couple of minutes late. Someone's nicked my meeting room. If there's anyone here from my building, can you turf them out before the 3 o'clock session, please, so I can move up to the proper room? That'd be good. So, today's session is about roof coverings under requirement B4. What we're in currently is our pre-webinar. So this is the kind of half-hour warm-up where we go through some of the information that leads up to the main session, which starts at 3 o'clock. So thank you to everyone who's dialed into this. If you stick around till 3, you get the full session, but we've got about 20 minutes of just build up to get us some a bit of a level, a bit of information in advance of that. So Becky, if I could borrow you another second, when I hit next, do you see my next slide here? Is it on the disclaimer?
It is. Thank you very much.
Thank you very much. All right, cool. So disclaimer, we have a video for this, but I couldn't get it to play annoyingly, so I'm gonna have to read it. Do forgive me for that. So the disclaimer for any of these webinars, if you've been to them before, this will be familiar. Any views or opinions expressed or implied on any matters by the authors, presenters, or participants during or in connection with the content of this presentation are solely the views of the authors of the respective comments and or opinions and must not be taken to be the views, position, or policies of the IFE. The IFE makes no representations, warranties, or assurances and accepts no responsibility for the content and or accuracy of this resource. The IFE shall not be liable for any damages, including without limitation, direct, indirect, incidental, special, punitive, or consequential damages that result in any way from your use or reliance on any content of this resource. I will, when we start the main session, have to repeat that for anyone that's dialed in just for that session, so forgive me. Next month, we have a nice glossy video that shows it. It's better than me reading it out, but I couldn't get it to work, sadly. So, yeah, you'll hear that again shortly. A quick introduction to myself. So my name is Joe. I am the president of the IFE Yorkshire and Humberside branch. I'm a fire engineer by profession. So I have a degree in fire engineering and a master's in fire and explosion engineering. Day to day, I work at Delta Fire Engineering, Delta R&D, and Delta Fire Training. So I spend my life doing fire strategies, training people to do fire strategies, and working in our lab on R&D projects. I am the founder and CEO of the Innovation Group, Delta Innovation Group, based myself at our lab and our campus up in Preston. Everything that's in this presentation, regardless of the disclaimer we've just had, is fact-based. This isn't my opinion, I'm just presenting what the guidance says. So this has come from our curriculum of our kind of taught fire engineering and fire risk assessment curriculum. So it should be familiar, probably familiar to some of you who've seen some of the slides before, but it's all good content, and I'll explain the levels when we get into the main session. Just a slide of us as a branch. So the Yorkshire and Humberside branch is one of the many 20-something branches across the UK representing the Institution of Fire Engineers. We relaunched the branch in January. Myself and the committee of Bassett, Becky, Jack, Joe, that's myself, Catherine, Kirsty, Lamar, and Tia. We've been working really hard over the last few months to get the branch up and running again after a period of it not operating. None of us were involved in the branch prior to January, but over the last few months, we've built it up to the standard that we're at now. A big part of our commitment to our members is the monthly webinars, which this one is. This is a session of. Our aims generally are to raise awareness, share knowledge, and spotlight our members. If you're interested in what we're doing as a branch, check out the website, follow us, see what we're doing. But we're going great guns, so well done to all the guys there from the committee. Again. A quick note about the webinars. What we do every month is we run a technical session webinar. Last month, we ran a session on something. What did we run a session on last month? Can't remember. We did something. This month it's roof coverings. Next month we're doing lightning protection. We always pick something that we feel is pertinent within the fire industry or a request from a member. So if you have something that you would like us to run a technical session on, do get in touch and we'll either write a session or we'll source somebody that's an expert in it who can deliver that for you. For all of our webinars, we do this session first, which we call our early careers pre-webinar. And really this session in advance of the main piece at 3 o'clock is a bit of background information. Today's has got some extra information, some reading around the subject, and just a leveler so that you don't get into the webinar and get lost within the first couple of slides. So that's what we're doing just for the next few minutes. The reason that there's some repetition is because basically we get to a point here up to requirement B4, and that's where we pick up the main session, and there's just 2 or 3 slides that repeat. But really this is targeted for our early careers colleagues that we've got hopefully on the call today. A little bit of contents, starting with our early careers, we'll talk about what a roof is and why we care about it for fire safety. The provisions for fire properties for roofs, so what do we design? There are some areas outside of the main session today that I'm going to touch on in the early careers pre-webinar. And then we'll land on performance requirement B4, which gives us our legal duty to assess fire properties of roof structures. And then in the main session, we're going to go through the mechanisms for fire spread. We get a slide on that in the early careers section as well, but talking about how a roof fire might start and spread. Then our requirements, what the guidance tells us we need to do for roof coverings, and then our 4 test classifications. There is one question that this webinar really seeks to answer, which is what is B-Roof T4? What does that mean? So that's a classification that comes up very often. I see it in strategies. I see it come from approvals authorities, building control, fire service, the HSE, the building safety regulator. It needs to be B-Roof T4. And very often when I hear that, I say, okay, explain that to me. What does B mean? What does T4 mean? What's the T? What's the 4? And I don't see that response very often from people. So that's what we're going to get to by the end of this session. If there is a learning outcome, it's that question. What is B-Roof T4? And I just added a slide in at the last minute. Obviously, the session was written weeks and months ago, but I added in a final slide about thatched roofs that I thought might be of interest from something I saw on site last week. So we'll finish on that at the end of the main session. So, definition of a roof. Well, our kind of simplest definition of what a roof is it's the top covering of a structure. It's designed to protect the interior, so we can't have an internal compartment. We can't really have a building without a roof that completes it at the highest level. And it's there to perform various functions, including protection from elements like rain, snow, wind, and sunlight. Getting into a slightly more technical definition of what we would consider to be a roof, our specification in terms of building design, and certainly for fire safety, is any element of an outer roof level or a section of external wall at a greater than 70-degree angle to the vertical plane. So if we have an external wall and it pokes in more than 70 degrees, that becomes part of a roof structure rather than an external wall. And one thing to know and to bear in mind, if we're not aware of this already, is that a roof structure is a complex build-up of various different layers. Within a roof structure, we have an outer covering that we see, which may be a piece of felt, it may be some tiling, it may be some gravel deck, something like that. It may be timber shingles or thatch. Underneath there are various levels. And when we're specifying fire engineering solutions and compiling fire strategies and carrying out FRAs, we need to be cognizant of what's underneath there, because we will have some type of substrate that the roof structure is affixed to. We will have an element of structure underneath. We'll have the eaves and the columns that could support that roof. We'll have various layers in there for waterproofing, various other things we're trying to achieve. So the first thing for us to know of our roof definition is that the roof is not just the thing that we see when we look at it from above. It is every component within there that makes up that entire roof system rather than just the outer surface. And now discussing fire safety now, coming into the mechanisms for fire spread. The image on the right-hand side will be really familiar to anyone who's picked up BR 187, the guidance document for external fire spread calculations. There are 3 predominant methods of external fire spread. We consider these to be direct flame impingement, radiant heat spread, and burning brands. Now, direct flame impingement is as self-explanatory as it comes. It is a flame physically touching another surface and spreading to it. Consider 2 buildings really close to one another, flashover occurs, breaks a window, flames protrude from that broken window and hit another surface and spread. That's direct flame impingement. Secondly, we may get radiant heat, which is the spread of heat flux and across 2 surfaces without direct flame impingement occurring. So it is spread without physical contact of the fire. Very common mechanism for fire spread between buildings. When we do space separation, we're generally designing so that the heat flux from our emitter is not sufficiently high that it'll ignite the second building across. If we look on the image there, it's that big red arrow from building A, the burning building, across to the building that's not yet involved. And the third one, and perhaps our most predominant for roof coverings, is burning brands. So it is elements of small fuel packages from a burning building that spread either via wind or via what we call convective currents. So the wind that's created by the fire itself, forcibly moving those fuel packages over a long distance. And again, when I was going through these slides just before I presented them this afternoon, I was thinking about where we've seen this example recently or notably in the news. And we've all seen, I'm sure, wildfires happening in increasing severity in the UK, but also globally. We just had in January the really significant fires over in Los Angeles. One of the main fire spread mechanisms over there in California was burning brands. So the combination of very, very dry conditions in California for 12 months, there were 365 consecutive days with no rain, resulting in drought conditions, with really, really strong winds. So the Santa Ana winds that whipped up in January in California caused this really significant wildfire event. The predominant fire spread mechanism there was, as we see in the image, burning brands. Now, these burning brands are up to, I mean, they can be larger, but up to typically the size of about a £2 coin, but they can travel and retain their potency for hundreds of meters. They may travel 400, 500, even 600 meters up towards half a mile, land on a surface, a dry material, and cause a secondary ignition of that. Now, if we're a frontline firefighter, part of a strike crew, for example, fighting the flame front, and a single brand can leapfrog our position and land on another material 800 meters potentially up the valley and cause a secondary fire, it's not difficult, believe me, it's not difficult to find yourself in a position where you are surrounded by fire in a really large 40,000 acre potential fire size. 70,000 acre actually was the peak of California. Now, for us, going back to what we're talking about today, our external walls and our roof structures therefore have to be resilient to these burning brands, as well as direct flame if we're close to other buildings, and radiant heat if we are in built up areas. An opportunity for me to just show some of our research here. This is a piece of apparatus we've designed within my team, the Bergham Hart Tunnel with Catherine Bergham, who's dialed in, I think, one of my collaborators here. We've designed a tunnel to model burning brands. These are a couple of different tests. So on the left-hand side, we were looking at whether if we have a single fuel package, if the effect of wind can create small embers that travel down the tunnel, and we can measure the how far they've traveled using the lines we painted on the inside of our tunnel there. We were hoping to get a couple of embers. You can see on the left in the image that there were hundreds that came from it. And when we continued that research, I've got an image here. I couldn't put the video in genuinely because there was too much swearing in the video. But an image there, we can see that what's happened is once we've got those embers flying and they land on combustible material, we get a secondary fire. On the right-hand side there, the ground, the grass, the dried out grass that's on the ground floor there, once touched by an ember, has caused secondary ignition, and the wind is driving that. You can see the direction of the flame. So those are the kind of mechanisms we come across when we're designing our roof coverings under the building regs. Now, to bring us onto our building regs and our kind of requirements for roof coverings, we start with the highest level, what the building regulations are, our functional requirements. Now, again, this session here is for our early careers, so I will assume there's no knowledge on this topic. If there is, you've just got a head start. That's fantastic. For anybody who is unaware, and I'm pitching to you guys in this early careers section, the building regulations provide our requirements for all buildings when we're designing them, or if we are upgrading them, or we're carrying out an alteration. We must meet various different sections of the building regs. Part B relates to fire, and within Part B there are 5 sections, B1 to B5. What these functional requirements do is they tell us what we need to achieve, but not how we need to go about achieving it. The example is for means of warning and escape on the right-hand side there. It tells us the building should be designed and constructed so there are appropriate provisions for early warning of fire and appropriate means of escape in the case of fire from the building to a place of safety, etc., etc. It doesn't tell us what's appropriate. That's for us to define as designers. It doesn't give us absolute requirements. You must have non-combustible roofs in these situations. It just tells us in the example of B1 that we must have appropriate means for warning and for escape. Similarly, when we get onto B4 external fire spread, which is where we end the early careers session, it tells us we must have appropriate means to prevent fire spread from occurring. Doesn't tell us what that is, doesn't tell us the boundary distances. We just have a legal requirement to satisfy the building regulations, performance functional requirements. Now, before we come on to the main session, which is about B4, really about our external fire spread and preventing spread from roof to roof or wall to roof or roof to wall, there are some other sections of the guidance where we would look at roofs. And I'm covering that in here. And this really is what the main session doesn't cover. Because if you sat the main session and you thought that's everything I need to know about roof fire safety, that would be disingenuous for me to say that. There are some other sections which I wanted to cover in here and to start to get us thinking about fire safety of roof structures as part of building design. So under requirement B1, which is means of warning and escape, there are some circumstances where we would look at fire safety of roof structures. The first one of these is if we are using that roof as an escape route. So if we have a flat roof, for example, over a section of building, and as a requirement of our escape strategy, occupants would enter that roof space, traverse across it, and either use an external stair or re-enter the building. That becomes part of the escape route. And we then, under requirement B1, have to put certain design parameters in to protect that means of escape. First of those is the building has to be under the same ownership as the roof that's being used. No what we call reciprocal agreements. I've just been dealing with a reciprocal agreement last week on site, actually, where one building had an evacuation strategy that relied on escaping via next door's roof. And they had a legal document called a reciprocal agreement, which said, you will always maintain that roof to be safe for us to escape. And in exchange, we won't lock this door. So if you are on the roof and you're evacuating your building, you can come into ours. Now, what had happened was somebody had broken that agreement. Fire safety in those two buildings was therefore compromised. And we were trying to legally come up with a solution where we didn't need that escape. So that's something we've come across where we've got roofs that we're using for means of escape. Similarly, if we have a section of roof that we need to use, we have to make sure that's fire rated, usually 30 minutes minimum, generally higher though, in my experience. And also that we have suitable fall protection. So if you've got people escaping over a flat roof, you've got to make sure that the edge of that roof is clearly delineated and that there is suitable protection from falling. So guide barriers, emergency lighting, signage, all that good stuff. So when we're looking at roof fire safety, performance requirement B1 will kick in if we've got a means of escape over a roof. There is also a circumstance where B2 would kick in, internal fire spread linings. Now you may think, well, that's internal to the building, but there is a circumstance where we have to draw on that and we have an obligation, and it's where we have roof lights on a roof level, because the internal side of those forms an internal lining and the external is part of our roof structure. So we may in actual fact find ourselves having to fire rate roof lights if we are passing within a certain distance of those as part of our escape route on the roof. But equally, if we're on the topmost story and we're looking up and we can see the underside of the roof light, there are circumstances where we have to make sure that we've got suitable fire rating to those roof lights. Specifically, that's where we've got rooms and circulation spaces underneath. It's not permitted to have those in critical escape routes like stairs, but say we've got a corridor and we've got roof lights to give us suitable ambient lighting. If they form part of the roof structure and an internal lining, we've got an obligation under B2 to make sure they're suitably fire rated. Another circumstance of this is structural fire resistance. So if our roof is just a roof and people go up there only for maintenance and there's no other reason to go up there, we generally say we don't need fire protection to the structure. However, if that is an occupiable space, so if we've got car parking up there, for example, if we've got a roof terrace, if that roof is converted to a roof terrace, which is so common in residential buildings, colleague that's dialed in, I know we're working on one in a hotel where they're converting an existing flat roof into a roof terrace. They're introducing kitchens and all sorts on there. We're having to go and look at the structure and say, do we need to remediate that topmost story to make sure it's got suitable structure? These are the kind of questions that come up in roof fire safety when we're looking at conversions or even new build. So where that roof also performs the function of a floor, whether that's as permanent occupation, perhaps we're building a new set of flats on top of an existing building, doing a vertical extension, that's becoming an occupiable story. Whether it's the use of that roof is changing, we're going to be adding in some barbecues and terraces and all that good stuff, and we're having parties up there at New Year, that's becoming an occupiable story, although not in constant occupation. Or if it just serves the function, if it's an open deck car park or something, then we need to make sure we've got fire rating to there. In the absence of any of those things, generally under B3, structural fire resistance, there's no reason, there's no obligation to fire rate that roof structure. Except, and it is something to be really aware of, if that roof is intrinsic somehow to stability in the building. It is not uncommon to come across a case where the external walls of the building are tied back in at roof level, and if you remove that roof, or if that collapses in a fire, you also lose, you get what we call consequential loss of the external walls, perhaps the cladding system. Then we also have to fire rate the roof. It's why it's important as fire engineers and fire risk assessors to know enough about structural engineering to know when you've reached your limits. Really important to be aware of that with roofs. I see very often people saying, the roof's not occupied, doesn't need to be fire rated. When you start to delve into the structure, you go, yeah, but my test for this is if you remove that element, does everything else remain in place? Think of a Jenga tower. If you remove that critical piece and the whole thing collapses, if you remove the roof, do the external walls still tie back appropriately to the foundations of the building? If the answer is no, it needs to be fire rated. So B3, we may find ourselves looking at fire protection to our roof. And then the final one, my slide's gone a bit dodgy there. I've gone over the text a bit. Again, in structure of the building, internal fire spread, structure B3, where we've got a compartment wall on our top story that interfaces with a roof structure, we need to make sure we've got some fire rating. We'd obviously put fire stopping at the head of that wall, but we also have a requirement either side to make sure that our roof is fire rated. And the reason for that is to make sure, or to try to mitigate a fire breaking out of a compartment, spreading across the roof and back in again. So to prevent that kind of bypassing of our compartmentation, we'll find ourselves fire rating a strip of ceiling, or strip of roof rather. 1500 mil either side of the compartment wall. The image on the left-hand side on screen there shows us that, where you've got the head of wall detail on the top story interfacing with the roof. 1500 mil either side, we have a specification that we need to achieve. As an alternative to that, we can have an upstand. So you can take the compartment wall up, 375 mil, the guidance gives us. Again, it's there to mitigate the exact same thing. Prevent a fire breaking out of a compartment, spreading across and back in again from above. In the new 9991, I want to say it's in, there's a really nice diagram of this actually that shows the flame coming up and being kind of not being allowed to impinge along the roof surface. So that's the fourth of our scenarios that we may come across where designing roofs involves the functional requirements B1, B2 and B3. But it leads us to where we want to finish this pre-webinar because it's where we pick up the main session at requirement B4. Now, like any of the other functional requirements, this tells us what we need to do, but not how to do it. B4 relates expressly to external fire spread, and it tells us that we need to, under part 1, adequately resist the spread of fire over walls and from one building to another, having regard to their height, use, and position of the building. And under section 2, we have to do the exact same for roof structures. So we have a legal requirement here under requirement B4, part 2, that the roof of the building shall adequately resist the spread of fire over the roof and from one building to another, having regard to the use and position of the building. We don't have a definition for adequate in the functional requirement. Our guidance gives us some information on that, and that's what the main session today is about. But we know now that we've got this legal duty. Because it's a regulation, we can be prosecuted if we breach it. If we have an incident in the building, we have to defend how we adequately designed against that requirement there, the functional requirement B4 part 2. So to summarise that little early careers, and then we come into the main session, which will start in about 5 minutes. We'll have a quick break between. We are looking at roof structures in this webinar today. That involves every part of the roof system, not just the outer surface that we observe if we looked at it above from a drone or something like that. We have lots of different situations in which for fire safety, we have to take a look at a roof structure. That could be for means of escape. That could be the internal lining if we've got a roof light. It could be the structure if it's used as an occupiable story or if we're converting to one. But principally, we've got a legal requirement under requirement B4 to make sure that we don't, or that we have adequate protection, adequate being the main word, from building A to building B or breaching a compartment within our building. So that's our early careers webinar session. That's a bit of a leveler, bit of a warm up. We give ourselves now 5 minutes before we come back. What I will do for the guys running the session, I will leave my screen sharing on this page here. I'll turn my camera and mic off though, and I'll dial back in about 4 minutes for the main session starting at 3 o'clock. So brew time, and I'll be back on shortly. So, good afternoon, everyone, or good afternoon again for those that we've just been speaking to in the early career session. Hopefully you can all hear and see me okay. If there's any issue, the guys on WhatsApp running the session, you can just let me know. I've got that open. But otherwise, I'll crack on. So, welcome to our webinar for May 2025. This is on roof coverings and specifically kind of B-Roof T4 kind of specification and testing standards for roof structures. I think there might have been some issues from the IFE of issuing invites to this. We're starting to realise. So if you have had an issue, apologies. We'll speak to IFE headquarters about that and get that resolved. One thing to note is that there's another session straight after this at 4 o'clock, so we may not have time for questions. I'll see how we do for time, but we need to tip out about 1:45 so the next session can set up. If you haven't had any issues, let us know and we'll make sure they're resolved for next month. But cracking on with what we are doing. So as I say, Yorkshire and Humberside webinar technical session for May. This month we're focusing on testing and classification of roof coverings. This was not a direct request, but it was one we discussed with enough people. We thought it warranted doing a session on. So it's one we've been looking forward to. A couple of little bits of housekeeping. Please note that the webinar is recorded, and we ask that you keep cameras and microphones off just to help with the bandwidth. Any questions you have, you can add to the Q&A and chat function. As I say, today we happen to be a busy day at the IFE in terms of the Zoom account, so we may not find time to get into each of those. If not, I'll follow up with each of them after with an email. One of our standard disclaimers, please do be respectful of the presenter, organisers and fellow delegates throughout the talk, and we do welcome feedback after the session. So we have started this programme just last month. This is our second session that we're doing. If it's useful, let us know. If it's not, let us know. It's all useful for us to help form and shape where the branch is going. We've got our email address info@ifeyorks.co.uk, and we've got a LinkedIn page and all that good stuff, so check that out if you find it useful. I will do the disclaimer again. Apologies to anyone who's already heard it, but I will have to do it again for any new joiners. So any views or opinions expressed or implied on any matters by the authors, presenters or participants during or in connection with the content of this presentation are solely the views of the authors of the respective comments and or opinions and must not be taken to be the views, position or policies of the IFE. The IFE makes no representations, warranties or assurances and accepts no responsibility for the content or accuracy of this resource. The IFE shall not be liable for any damages, including without limitation, direct, indirect, incidental, special, punitive or consequential damages that result in any way from your use or reliance of any content of this resource. Phew, there we go. Right, so some of us have been in the early careers, some of us haven't, so I will redo these couple of slides here. My name is Joe Hart, for any of us that don't know each other. I'm the president of the IFE Yorkshire and Humberside branch. I am a fire engineer by trade, by profession, I suppose. Degree in fire engineering, master's degree. I'm now head of fire engineering over at Delta. I'm also head of R&D, so I run our research lab and research program, and head of curriculum development at the Delta Training Academy. We teach fire engineering, FRAs and all that good stuff. The content of this session, for anyone who is interested in this or wants to kind of gauge it, it's about level 5 this. So for anyone that is studying or has studied, it's about second year undergrad in terms of complexity and depth of content. The level system from level 2 up to level 7, well, you can go further, but broadly we speak in terms of level 2 to 7. It has nothing to do with the length of a course. It is all to do with the depth of content. So even though this is only a 40-minute session, it is about level 5. So just do bear that in mind. It's part of our level 5 program for fire engineering and fire risk assessment, fire safety management, whatever it is. So anyone who comes to sit those courses, you'll see these slides again. Very brief mention, the Yorkshire and Humberside branch, we relaunched this just back in January. I've got my committee tearing away on WhatsApp in the background. At the corner of my eye, I can see you all chatting away. Bassett, Becky, Jack, Joe, Catherine, Kirsty, Lamar and Tia, thanks again to you guys for getting everything up and running, doing amazing work. Everything we do as a branch, you'll find on our website, and our aims are always to raise awareness, share knowledge and spotlight our members. This program that we do, the webinars, is all about sharing knowledge. It's a monthly session that we do on a technical subject related to the fire sector, usually fire engineering if I'm speaking. If it was a colleague, it might be risk assessment, it might be strategy, it might be firefighting, fire investigation perhaps. We tailor these to what people want to hear about. So if you've got a subject, if something really annoys you, you don't know the answer and you think, I just want a bit of technical background in that, drop us a line and we'll write a session or find an expert who'll deliver it. For anyone who wasn't in the session, before every event, we also have a pre-webinar. That's targeted for early careers. It's a bit of a leveler. In the one we've just done, we talked about roof structures generally, how we might define fire safety and kind of why do we care about fire safety, talking about means of escape and stuff before we get to where we start the main session in just a couple of moments' time. A quick note and a promise from us is webinars are, and they always will be, free to attend for members and non-members alike. You don't have to be a member of our branch. You don't have to be a member of the IFE. We give this out for free. It's there for the benefit of anyone who's interested. If you are a member of the IFE, you can choose your local branch. If you choose us, you get a newsletter and some extra stuff. If you don't, regardless, if you're a member, you get recordings for each of these on the CPD portal of my IFE. So yeah, you can watch these back later. But I hope there's people here who are here, even if they're not members, just because you're interested. So yeah, welcome to, well, everybody is welcome at our sessions at the Yorkshire Side branch. So into the technical stuff then, roof coverings. This is kind of where we finish the early careers for anyone who's continuing into the main session. Why do we care? Basically, why do we care about roof coverings? Well, the roof of any building is likely to be exposed, and it is an element at risk of fire spread from two mechanisms. It can be fire spread from outside to in or inside to out. So if we consider we've got a fire elsewhere in the town or the city that our building's located in, if that fire is able to spread to an exposed element of our building is at risk. And secondarily, if we get a fire that breaks into the roof space of our structure and it can then spread external, it can spread around the building to adjacent premises, it can spread over the roof and back in. So we have a real big obligation for fire safety of the roof coverings themselves. If we have a fire at roof level, the two images we've got there look to be low-rise dwelling houses, but consider a 10-storey HRB. Firefighting at that height is a huge complexity. We've got unseen fire spread that may occur. So we may be fortunate enough to be able to get up on an ALP. We might have a drone we can throw up, but otherwise, if we're stood at ground level, it may not be fully clear to us that we have a fire at roof level. And even if we identify it, firefighting-wise, we've got complexities getting up there. If we do get a sustained fire at high level, at roof level, we've got a risk that that could attack down into our building, result in collapse of that roof to the topmost story, result potentially in hazards within the building itself if we have collapse of roof into the structure. And we know as well, and we'll come on to discuss in the next slide, that it is a legal duty of us as designers under the building regulations to design to mitigate fire spread occurring at roof level from building to building, as well as in our building back into our structure. This is exactly where we left off the pre-webinar. Requirement B4. We know what the building regs are by now. We know how functional requirements work. It tells us what we need to do, but not how to do it. We have got an obligation under B4 Part 2 to adequately resist the spread of fire over the roof and from one building to another. Those are the two mechanisms I just talked about. Fire in our building, breaks to the roof, spreads across and back in. That's the first part. Second part, fire in our building. It shouldn't spread to next door via the roof. And similarly, if there's a fire next door or even further adjacent, in the pre-webinar, we talked a bit about wildfires. That wildfire could be 800 meters away. It might spread to our building. So we have an obligation to design against that hazard. So our building regs don't tell us how to achieve things. They tell us what we need to achieve. So we refer to our guidance. So coming into the first section of the guidance, we may find ourselves looking at the approved documents. Under approved document B, table 14.1, we've got classification requirements for roof coverings. Now, focusing our minds, refocusing to where we're at, we've got a legal duty to design roof coverings safely for fire to adequately resist spread of flame. We go to our guidance and we seek guidance. We seek design principles of what to put into our building, and we land at this table. Now, what this table tells us here is we've got different requirements for roof coverings based predominantly on the boundary distance. So how far our roof is from adjacent properties and adjacent boundaries. And in the table there, if we look, we've got black dots there are acceptable, white dots are not acceptable. So it tells us that on the left-hand column, we have these terms coming in, these designations, B roof T4, C roof T4, D roof down to F roof T4. Each of them have got T4 in brackets. We'll come on to what that means. And we've got B, C, D, E, or F. And as we move down the table, they become more onerous, or you could infer less safe or less fire protected as you come down from B to F. You could say that B roof T4, looking at that table, is clearly the highest rating, because if we look at what's acceptable, we can use that less than 6 meters from the boundary. Whereas F roof T4, we would infer that that's a lower standard of rating, because that's only acceptable to be used where we've got 20 meters of separation. So what this table gives us is this direct proportionate effect, that the closer we are to a boundary, the higher classification we need for roofs, and that designation works by the lower the letter, if you like, the earlier in the alphabet, the higher the safety is, therefore the closer it can be to a boundary. So straight away, we've got a bit of a design principle there. We're looking at how close our roof is to a boundary, and we're going to specify it according to the designation of B, C, D, E, or F, and we're always going to use T4. Now, as I said previously, the main output from this session really is to answer the question, what is BROOF T4? The number of meetings I've sat in with colleagues or students or academics, building control, BSR, fire service, who just throw BROOF T4 at me, and I shoot back, what does that mean? And very, very blank faces. By the end of this session, I want us to really understand what that means, that designation, and how we get there by running through the test standards to get to it. I am a massive advocate for this and have been for a long time. I don't expect anyone to know who I am or follow anything I do, but if you do, if I've ever taught you or we've worked together or we've worked on projects, lots of you will know that I'm a huge advocate for fire testing. I think it's such important knowledge. I write it into every curriculum that I write. I'm teaching a level 3 fire risk assessment course next week. We've got about half a day on fire testing because I think it's such important knowledge, and that's what this session is about, really. Just to nod to other sections of guidance to show that it's uniformed across each of them, and to bring in a little section about national class. We'll see that although it's presented slightly differently, we don't have the black and the white dots. We've got the same guidance in 9991, which is our residential standard, and 9999 for commercial. So again, closer to boundary, the higher the classification rating we require. In 9991, which only came out recently, we've got the exact same designation, B, C, D, E, and F, all to classification T4. If we're less than 6 meters from the boundary, i.e. higher risk, we've got the lower class, that's class B. And as we get up to 20 meters away, really large boundary distances, we can drop our designation down to class F. 9999 on the right-hand side there gives us the same. 9999 is used for commercial fire safety strategy design, but we see another class in there, the national class, which is given in terms of letters only. Doesn't mention brackets and T's and all that kind of stuff. AA, AB, AC, BA, BB, blah, 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 blah. That exists in 9999 only because 9999 hasn't been updated relatively recently. Those classes existed in previous iterations of Approved Document B and in previous iterations of 9991. Now, what they are is the old national classification for roof coverings, and the European class is what we recognise now to be B, C, D, E, F, with T4 there in brackets. In updated standards and current standards, we are shifting to the European class and dropping the national class. I expect the next version of 9999 will not mention that column that I've got the arrows pointed at. And similarly, we will all be familiar, I expect, if we use the approved documents, with our current transition arrangements. So in the latest versions of ADB, we've got things that are being phased out and removed. We've been given 5 years to phase out entirely the national classification. That's the AA, AB, BA, BC, etc., etc. I snipped this from the latest ADB, which comes into effect 1st September 2029. You'll see it says in here it only references the European classification of 13501 Part 5, which is what we'll talk about next. The national class is not to be used at all. But for that reason, I've got this previous slide with a bit of a nod to the national class, but I don't talk about that in this section, in this session at all. In fact, we look only at the European class. Personally, as a designer, I only include European in my strategies now. If I'm doing a bit of work on an existing building, I might have a national class certificate. Because we're in a transition arrangement, that's still okay to use and reference. But I'm not specifying new materials now under anything but the European class. So for that reason, I'm going to concentrate on that Euro class for the rest of this session. I did just want to make reference to it, though, in case anyone was wondering what those old sections mean. Now, back to our sections of guidance. Underneath each of those designation tables, there is a note, and it is a really important note. And I always like in these sessions to give really good little nuggets of knowledge. I call it in my team, anyone who's dialed in will know, things to have up your sleeve. They're just good little bits of knowledge, things to just be aware of in the back of your mind. If it comes up in a meeting, you've got the information there. This is one of my favorites because the section underneath the table for classification of roof coverings, beg pardon, it is one of the only references that still exists in our guidance to cubic capacity. So cubic capacity, meters cubed, rather than meters squared. And it's so useful to be aware of that because this will catch people out. And I know that because it's caught me out. You absolutely become a better engineer by making mistakes and hopefully catching them before they cause problems. But this has caught me out early career and, dare I say, late career as well. Essentially in the notes section here, under the table, it says for some of the designations that are given as acceptable, not acceptable, there are exceptions. And one of those is for Class D. So we'll come on to what Class D is. We'll know all about that in about 15, 20 minutes time. Class D is not permitted in certain circumstances, and Class E is not permitted at all in these same circumstances. And what they are is industrial, storage, or non-residential of any size. So that's a huge proportion of buildings. We've got to be aware of that if we're using the table. Always, always, always. Again, people in my team will know this. I always say if you're looking something up, read the section before and the section after. Just help place that thing you're looking up in the guidance. I've been doing that for years now. If I'm looking up a travel distance, instead of just looking up what's the travel distance for B2, 20 meters, 23 meters, blah, 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 I'll read the whole section and you just get some contextualization, because if you don't read the notes, sometimes you miss a key point like this. So if I flick back just a couple of slides, this is where we've got note 2 and note 3 for that 6 meter criteria. Even though it says it's acceptable, it's only acceptable in certain circumstances, and it's not acceptable in any non-residential building. That's a huge, huge proportion of portfolio projects, isn't it? So we need to be aware of that. And the second one is any building with a cubic capacity of more than 1,500 meters cubed. Now, again, I promise this is true. I don't expect anyone to know my background or where I've come from or who I am and what I research, but I spend a huge amount of my time researching the post-war building studies and the kind of development of guidance over time. And one of the big things that I find interesting is how infrequently these days we use cubic capacity, and we've favoured floor area these days. The new 8674 standard for fire risk assessor competency talks about if it's greater than or less than 600 meters squared, whether it's intermediate or high risk building. That's an interesting number. I don't know where it comes from, admittedly, but I'm going to find out. That's my research theme, to pick these numbers. In original guidance, go back to the 1950s when we were developing guidance for fire safety, everything was cubic meters. Very little of it was floor area, but now we've got just very few residual bits of that. We've got one here, 1,500 cubic meters, specifies our roof covering. It's a really good one to have up your sleeve, as I say. So when we're specifying this in a fire strategy, broadly, we'll be looking at a couple of things. What's the use of our building? How close is it to the boundary? From there, we can read from our table what our roof covering specification is. Now, we're still not really any close to knowing what B, C, D, and F mean. That's what we're going to do next. But we know now we can come to this table, and let's say we've got a building, the example at the bottom there, final bullet point, a building that's greater than 20 meters from the boundary in all directions. That means that B roof T4 fire rating should be specified. If it's less than 6 meters, we've got, if it's less than 6 meters, we've got B roof T4 in any case. It can be F roof T4 if it's more than 20 meters in any direction, apart from those 2 exceptions we've got, which is cubic capacity of 1,500, or if it's non-residential. Now, there is a good little reference in here, one that's really useful to have on your desktop or in your resource library, and it's a European directive that talks about classification materials without the need for testing. So if we have a material on a building, this could be something we're looking at retrospectively or specifying on a new building. There are some materials where we don't even need to get into understanding what the classification of it is, because there is existing data that tells us it will be acceptable. The European directive for this is 2000/553/EC. You'll find reference to this in approved document B and 9999991. It's free to download. If you tap it into Google, it comes up. You can have a read of this. And what it says in here is, given certain parameters, these materials are deemed to satisfy the requirements for roof coverings and not adversely impact roof penetrations, lateral fire spread along the material, fire resistance of the roof deck itself, and all the other things we'd be looking for in terms of fire resistance and reaction to fire. These include the types of material that you would expect to just meet the requirements anyway: slates and tiles, fiber reinforced cement-based products. In some cases, they have a minimum specification. So on the right-hand side, I've plucked that from the European directive there. It says, for example, if we've got profiled metal sheets of aluminium, as long as it's greater than 0.4 millimeters, we don't need to do anything further. That meets the classification. As long as any material coating has got a PCS, I'll explain that in just a second, of less than 4 megajoules per meter squared, or a mass rate less than 200 grams per meter squared. So as long as if we're specifying this in a strategy, or we're looking at an existing condition, we can come to this table, and before we even get into the weeds of test data, we can think, if we meet this and we meet the criteria on the right-hand side, then it's acceptable, and we can accept that to meet B4 of our strategy. Two quick notes on here. The second one definitely more important than the first one. The first one just defines what PCS is, because you see that in this table an awful lot. That's the gross calorific value, essentially how much energy a material holds, and you determine that generally using bomb calorimetry. You take a small sample of it, about 50 grams, powder it up, run it through an oxygen bomb calorimeter. It tells you its calorific value. The exact same test you use to work out calories in a Snickers bar. It's just the food material tester, but we can also use it for energy in a material. And when I was writing this slide, I just had to put in that extra note because we've got a bomb calorimeter in our team and we use it for exactly this type of work, mainly for like cladding. If we're doing an FRAW, you've got a piece of insulation. I wonder what its calorific value is. If you chisel a bit off, we'll tell you in the lab. One thing to be really aware of, because I think you could read this table incorrectly and accidentally do it, do not ever put aluminium in a bomb calorimeter. So don't ever try to work out the calorific value of aluminium. I think when you look at profiled metal sheets and it says aluminium, as long as it has a PCS of less than 4, it does say external coating and it means external coating. If you put powdered metal into this calorimetry, the word bomb really comes to precedence. It really does destroy your equipment and your lab and probably half of the town you're in as well. So just a note to be super careful about there. But we can use this classification without need for further testing. Very quick note as well, just about boundary distances, because this comes up from time to time, and we get asked this quite a lot about what is the relevant boundary. On a set of floor plans, we'll usually have an ownership boundary, red line boundary, that tells us where the legal boundary completes. That means that no one's going to build up to that because it's our land, so we may take that. We may otherwise, these are the definitions from the guidance, take a notional boundary between two buildings on the assumption that our building and that building exist coincidentally, and we've got a boundary halfway between them, and we'll design to that. Remember, this is of importance. If we're looking at whether we're less than, greater than 6 meters, up to 20 meters, this will determine our requirement for roof covering. And typically, just as a notional boundary, bit of an engineer's hat on here, I'd say, well, my notional boundary for that property, for example, on the right-hand side, I would take that to halfway across the river. It's deemed acceptable to do that. If you've got a piece of land that is unlikely to be subject to future development, so you've got a road or a river or a pathway or a bit of protected greenbelt park or something, it's extremely unlikely anyone's going to buy a road and develop it. It's a long, thin piece of land. It's a strip of land that's being used for infrastructure. It's unlikely you'll get a building, so we tend to take to halfway across that space. Same like railway lines and streams and canals and stuff like that. So just a quick note about how we'd measure the boundary distance. Now, coming on to our actual fire testing, really the important part of this talk. What I want to delve into is answering that question, what does B-Roof T4 mean? So what does B mean? Roof just means roof. I don't need to explain that, hopefully. What does T mean? What does 4 mean? And we can break it down in that way. There are 4 different test standards we would use for roofs, and they're all based around the primary or predominant mechanisms for fire spread we might find in a roof fire. They are radiation, they are direct flame impingement, or burning brands. Pre-webinar, we explain these in a bit more detail. Anyone who's in the main session, I hope we understand. This is from BR 187. Each of our tests is going to assess these to varying degrees of complexity. Each of them look at direct flame impingement. Some of them look at radiation, and I think each of them look at brands as well, actually. As we go through, you'll see it's kind of layered. And our 4 tests that we have for whoever's calling me on Teams, you're not going to get through, I'm afraid, unless you want me to answer live in the webinar. The fire tests are detailed in a technical standard, test standard called 1187 from 2012. That feels like a really old standard, and it is. It's currently up for review, this. Don't anticipate it changing a great deal because these tests have existed for a long time. But I often look at a standard and I think, well, if it's sort of 10 plus years old, am I using the latest version? But 2012 is the latest version for this. So we have got 4 tests. 4 individual tests that we'd carry out on roofs, and this gets us towards our definition of what B-Roof and C-Roof T4 would be. Test 1 is a method of testing roof cover materials using burning brands, and it looks like the image on the right-hand side. Down at the right there, we've got a basket. That's exactly the test apparatus we've got. And up in the top right-hand side, we've got the apparatus in use. So we have got a piece of roof covering, in this case, a green wool, and we've got a basket on top of it filled with wood wool and ignited. And that's the simplicity of this test number 1. Now, each of the roof tests that we've got have got a couple of different complexities in there. The first one is what's the substrate underneath? So what are we testing it on top of? Do we just stick a bit of AstroTurf on some timber and have done with it? Or do we use concrete? There's different benefits to using different materials. And the second complexity is the pitch. So what's the pitch of the roof we use? Now, of course, these materials could be pitched at any angle, any degree of pitch in a real application. So do we test every different angle? Do we test every different substrate? There are some rationalizations in the test standard. The way it works for this test number 1, the simplest of the tests, is there are only 2 pitches you have to test. One's 15 degrees, one's 45 degrees. That looks to me to be a 45-degree test in the picture there. If you test to the 15 degree, that applies to a real roof application anywhere from 0 to 20 degrees. So that's a kind of middle ground. That's a mean result that will assist for any of those. And if in the real world your material, is going to be over 20 degrees, you'd use that 45-degree test data. The methodology itself, you take the material, you pitch it at either 15 or 45, and you add a brand box, so a box that creates brands, on top, which is made of a wire mesh filled with 600 grams plus or minus a bit of tolerance of wood wool, and that's ignited, and the test is left to run for 60 minutes. And we take various observations during that test number 1, which we'll come on to after because we do each of the tests in turn in this presentation. And all we're interested in is the effect of burning brands landing on that material. There's no wind effect, there's no radiant heat, there's nothing else clever going on. It's simply burning material on top of a test specimen, and we assess for 60 minutes to see what the impact is. Each of these tests, as we go through them, gets more complex as you go up. So test number 2 has a very similar test apparatus, but it has the added effect of wind. So 1187, TS 1187, 2012 standard, test number 1 is just a burning brand sat on a specimen, pitched at either 15 or 45 degrees. Test number 2 is very similar. It uses a timber crib instead of wood wool. There's 8 pieces of pine wood that are balanced in a configuration. They're 100 mil in length and 10 mil cross-sectional 10 by 10. And they're placed on top of the test sample. There is only one pitch that's tested in test 2, just at 30 degrees, and that applies to any configuration you'd use it in. But crucially, what happens in test 2, slightly more sophisticated, there is wind coming from down below, set at 2 different speeds, either 2 meters per second or 4 meters per second. There is also a pilot burner, so a pipe burner down at the bottom there with different holes coming out. During the test, there's different configurations of these, trying to encourage the crib to ignite and the effect we see on the screen there to occur, which is that wind comes in, sticks the flame to the surface, propagates it up the side, and we observe to see what effect that has on the specimen and the substrate beneath there as well. Test number 3 gets slightly more sophisticated. Again, each test that we do gets slightly more complex and slightly more sophisticated as we go up. We use a much bigger piece of apparatus. You can see, probably familiar, that angled piece there. Test number 3 uses burning brands, wind, and the addition of radiant heat. So the way that this test works is we've got a specimen that is pitched at an angle. 2 different pitches be used, 5 degrees and 30 degrees. Similar to test 1, we've got tolerances in there. So if in the real world you've got an angle up to 10 degrees, you use the 5-degree test data. Anything above that, you use that 30. One thing that's worthy of a very, very quick note is if your material is only going to be pitched at a certain angle and you use that specific angle in the test, which you can do, that's absolutely fine. You get really accurate data for how that material will use or behave in a real fire, but it only applies for that specific data, that specific pitch that you've used. So if you have a material and it's only used on a roof deck that's at 22 degrees, you can test it at 22, only applies for it in that configuration. If it's installed at a different pitch, you can't extend the field of application of that test you've completed. The addition that we've got in test 3 is, as well as the brand box that's sat on there, as well as the wind that's coming in from below, we've also got the addition of a radiant heat panel, which we can see on the screen as the running parallel to the main deck. That gives out heat flux at 12.5 kilowatts per meter squared. Familiar number probably if we're familiar with external fire spread mechanisms, and BRE note 1001 is where we may find some data about that heat flux. One thing to be aware of, and the reason this is quite a sophisticated piece of kit and such a big piece of kit, is because bear in mind that this is under wind effect. So there is wind coming from below, which has a cooling effect when that wind comes through. That's not heated convective current that's coming through. That's just wind. So it's going to be cooling the material as it's blowing across the test specimen. So you have to have a thermocouple or a flux meter on the specimen to ramp up and ramp down the radiant heat being emitted to ensure that it's maintained at that 12.5. Really complex, really sophisticated piece of kit. The way that this test 3 works is the panel is ignited first of all. That's the radiant panel. And then after 2.5 minutes, we introduce the pilot ignition by way of 2 brands that are placed on there. Again, those brand boxes in the either the crib or in the wire mesh. The test then runs for 30 minutes. We take various observations, which we'll talk about in a second. The effect of using the radiant heat panel first, that is by far the best way round to do it, or at least the most onerous way to do it for the specimen. It means that we're preheating our material. It means we've got 2.5 minutes blasting that specimen at 12.5 kilowatts per meter squared, which we would expect it to be close to igniting at, bringing it closer to its ignition temperature, so that as soon as we place a direct flame on it, it's likely to ignite. So radiant panel always comes first, 2.5 minutes of exposure, then we add the secondary heat source as well. In addition, we've got wind coming from below, encouraging flame spread up the ramp, up the deck, again at 2 meters per second and 4 meters per second. There's 2 different wind speeds we use. And this is, as with every test apparatus, it's designed to encourage flame spread in the worst possible condition here. You can see just from the apparatus there, if you had a material that was combustible on the upper side of that deck, you blast it for 2.5 minutes with some radiant heat. You then ignite it with a secondary flame source, direct flame impingement. At the same time, you're encouraging that up the incline with some wind. It's likely that that material will ignite if it's combustible. That's the point of the test. And then coming on to test 4. Even more sophisticated. This is a 2-stage test, again assessing all 3 of those things. So assessing burning brands, wind, and the supplementary radiant heat. The added complexity and the added sophistication here is that there are 2 different tests completed. The first one of these, again, it always happens at 45 degrees, this one, except where it's going to be a flat roof system, in which case you just test it horizontally. But 45 degrees for any test, that as a critical angle is likely to encourage flame spread. So that's the first level of T4, test number 4, sorry, being a slightly more sophisticated than test number 3. We then do a preliminary test. So in the preliminary test, we again blast it with some radiant heat, and then we stick a gas flame on it. So we are literally just trying to ignite it with a flame, which is what's happening in the test rig there. You can see that we've got a 45-degree angled specimen. That's being hit with the radiant heat. Again, that's at 12.5 kilowatts per meter squared. Again, it's regulated to make sure that that's consistent. If you have background ambient wind or anything like that in the lab that's affecting it, it will regulate itself. It will ramp itself up or down to make sure that we've got consistent heat flux being exhibited on that specimen. And then after that, we come along and we literally put a flame on it. We put that flame on, we move it up and down over a 70-second period, I think it is, and we try to ignite it, essentially. And that's just the preliminary test. Because what we then do under test 4, using the same apparatus, is we turn on the wind, we leave it with the radiant heat there, and we run the test for 60 minutes total. Now, one thing that happens here, the last level of sophistication, if you like. First of all, actually, a level that I quite like in here. We talk in fire testing and fire exposure a lot about ramp-up time. And the ramp-up time is how quickly or slowly something is exposed to that heat. So sometimes when you turn a test furnace on, if it's cold and it's a Friday morning and first time you used it that day, it takes a bit of time to ramp up and all the surface linings need to, build up a heat resistance for the day and all that kind of stuff. In this test, and we call that ramp up time, how long it takes to reach its peak. In the case of test 4 under the 1187 test regime, it hits it within 5 seconds. So it goes from ambient to full exposure within 5 seconds at the start of the test, which simulates the building next door flashing over, window breaking, and very quick exposure to the flame source hitting our materials. At the same time, we hit it with wind. Now, 2 things with the wind that are really notable in here, and these are things that we need to be aware of if we're specifying these materials. First of all, the wind effect is much higher than previous tests. So test 2 and 3 use 2 meters per second, 4 meters per second. It's a greater wind speed at 6.7 meters per second in our test 4. And secondly, a really important method here. This image here is taken from behind the test rig. You can see there's a big section underneath. And what that is a pressurization chamber. And the way that wind is applied during test 4 is, instead of it being a fan at the base of the unit, it under-pressurizes, it depressurizes the backside of the unit, which encourages spread to come from the other side. It's actually drawing in the hot air from the radiant panel rather than having the cooling effect of a fan at the base of the unit, at the base of the rig. So as an extra added level to test 4, we've got higher wind speed applied in a very different way. It's hot wind, if you like, that's hitting it. It's a current that's coming from a radiant panel, and it's being applied via depressurization, so you don't get any of that cooling effect of wind blowing. So test 4 is far more sophisticated than test 3. Each of the tests as we go across get slightly more difficult to pass. They test slightly different things, and they become more and more sophisticated until we get to test 4, which we've got all of these different things going on. So again, to recap this test 4, what we've got is a preliminary test where we expose a sample at 45 degrees, which is the most critical angle, most likely to get flame spread up the side of the specimen. That's being hit with a radiant panel. We then literally hold an ignition source to it and see if it will ignite in our preliminary test. We then go on to our main test, which lasts for 60 minutes with the radiant panel attached to it. We've got higher wind speed at 6.7 meters per second coming in via depressurization, so it's not got a cooling effect coming in. And we've also got 12 kilowatts per meter squared coming in, plus or minus 1.5. It'll drop to 10.5, or it'll go up to 13.5 in this particular test. A little bit more tolerance for the incident flux in this regime. And that again is regulated. So if that drops at any point or goes too high, the radiant panel will ramp up and down. So it's less critical what the emitting flux is from the panel. It's far more important what's being received. So we need thermocouples and heat flux meters in the sample itself. So that's a bit of a whiz through each of the tests. And just to kind of summarize that before we come on to how we use that data. Test 1 is just assessing burning brands. That's up in the top left there. We get a sample, we put a material on it, we see if it ignites. Test number 2, we do the same, but we add some wind to the bottom of it by way of a fan, which has some cooling effects, but also spreads the flames up the test sample. Test number 3, we do exactly the same, but we add in a panel. So we're preheating the material with a radiant heat source. And in test number 4, we use similar apparatus, but we remove the benefit we get from cooling by we don't have the fan anymore. And it's a much longer test, and it's in 2 stages. So we'll try to ignite it first of all, and then we've got the second main test for 60 minutes with a radiant panel on it. Now, how do we use that data? We classify our materials based off of the formula on screen there, X roof TY. Now, what that means is X is a classification that's obtained during the course of the test, and Y is the test that we've done. So of our 4 tests, T stands for test, we've got test 1, test 2, test 3, test 4. It means if we have a material that is F roof T3, it means it's achieved class F in test number 3. If we've got B roof T1, it means we've done test number 1. That's the one just with the burning brands on, and it's achieved class B. If we've got B roof T4, dare I say, which is where we're going to try and land, it means we've done test number 4, we've achieved class B. So this comes under our European class 13501 Part 5. The 13501 series will give us all of our classification standards, basically telling us how to use test data to determine designations to use in buildings. And more for notes for watching after, rather than going through these in absolute detail. If you sit this as part of the course, we do it in quite a lot of detail. We'll see that there are different classifications for each of the tests because, of course, we're testing different things. So in test 1, what we're looking for is various things. We're looking at the external and internal fire spread across the sample. Are there any burning particles that have dropped on the roof deck and continue to burn? If they glow, how long do they glow for? What's the fire spread on the horizontal roof level? How far is the flame propagated? Once we've got all that result from our test, we can come to our classification tables. On the right-hand side there, we can see we'd get B roof T1 if we met all these criteria. In the absence of that, it's F roof T1. It'll only let you have B or F under test number 1. You'll never see C roof T1. Similarly for test number 2, we run these tests using the different wind speeds. We get our data and we look to our classification table. Again, for test 2, we can only have B roof or F roof. So if we want to do B roof T2, or we see test data for B roof T2, it means that we've achieved these 2 standards. So the mean damaged length of roof is less than 550 mil, and the maximum is less than 800 mil. If we meet those, we get a B class. If we don't meet those, it's F. But again, in brackets, because it's test number 2, it means that we've got T2 in brackets. Very similar for T3. There's a couple of little acronyms in here that are worth just clarifying. So TE is the external fire spread time, how long it burnt on the external face of the test sample, and the time to fire penetration, how long it took to penetrate the roof deck down below, and you could get loss of fire resistance from above to below. We can have B, C, D, or F under T3, and depending on when those things occur, will give us our classification standard. Again, T3 in brackets means it's test 3 that's been completed, and our classification is B, C, D, or F. And then the most prevalent one for us that we come across in fire, certainly in strategies and risk assessments, we see T4. These are our classification standards. We can have B, C, D, E, or F. B means that we've had no penetration of the roof system in the full 1 hour test. In the preliminary test, after we draw the test sample for 5 minutes, let me just move my thing so I can read that properly. Whoops, 1 second. And in the preliminary test, we get flame spread less than 380 mil across the region of burning. If we meet each of those standards, we get the B classification. If we get penetration of the roof system within 30 minutes, not the 1 hour, we'd have to drop to a C classification. If it goes within 30 minutes but doesn't penetrate in the preliminary test, it's a D, and so on and so forth. We take our test data from the 4th test that we'd complete, and we look to our classification table, and we read off from here. So in answer to our question of what this means, that we get asked in meetings so often, and that we very often find ourselves specifying and hopefully understanding now, but hopefully understanding, certainly if we've ever written it in a report, we should know what it means. What is B-Roof T4? Well, it's a material that's been tested to test number 4 of 1187, and it has achieved the following criteria, which gives you the B rating. So there's been no penetration of the roof system within 1 hour. In the preliminary test, after withdrawal of the test flame, specimens have burnt for less than 5 minutes. That's where they come in with a radiant panel, ignite it with a live flame source. When you remove that, it'll burn for a bit, but as long as it extinguishes within 5 minutes, it meets the B classification. And also in the preliminary test, when it's doing that burning region is developing, as long as that's less than 380 mil from where it is that you've put in that initial flame source, you'd meet B-Roof T4. So when we see material that meets that class, it means it's been tested to the right test and it's met those standards. Now, I added in just a couple of quick slides right at the end. I'm pretty much at the end of the session now. I've got about 2 minutes left, so yeah, this has worked well. Last week, I was driving down to somewhere, Somerset, with Kirsty, and Kirsty said to me, "Have you written that webinar yet, Joe?" And I said, what webinar? She reminded me I was doing a webinar today. And we were looking at some thatched roofs as we were driving through. Just beautiful bit of countryside. We got chatting about it, and it reminded me of the relevance of thatch and wood shingles to this topic. So I've just dropped in a quick note really to touch on it, and more of a reference to read more if you're interested rather than a bit of technical content. It says in our guidance that thatch and wood shingles will never achieve anything higher than an E-Roof T4. So if you test it under the 4th test regime, it's likely to get a class E and no higher. That makes sense, because if you think about the robustness of that testing with both radiant heat and brands as well as the pilot source, it is, I mean, thatch roofing is dry vegetation. It's straw, water reed, rush, sedge, palm. It's likely if you ignite it with both radiant heat and pilot flux, it will burn for greater than 5 minutes. It will spread more than 380 mil. So it's not unexpected, I suppose. But with thatch, just as a note, and again, the part of the world we were in last week, we saw it. There's a lot up in like Cheshire and other areas around where I'm based up here in the northwest. There's a significant fire hazard with thatch installations. Smouldering combustion can occur. You may not even see the fires occurring, and it's happening on the underside or within the thatch itself. Really complex firefighting. I was speaking to a firefighter about this not so long ago. He said it's like 24 hours that you'd be at a thatch roof property. Even when you think the fire's out, you're driving back, you get the call, you shout out again, you come back and it's still going. So lots of damping down needed. And there is just a quick reference here for anyone who comes across thatch and is looking at roof coverings. You will struggle to apply this standard methodology to it. There's no real benefit to looking at your boundary distances and saying it needs to be B roof or C roof. You'll never achieve more than E. But there is some design guidance for it. That's, again, a good one for up your sleeve. I've put a reference on there. I wrote an article about this a couple of years ago. There's a reference that's on our website. When I Googled this earlier today, when I was writing this slide, our website came as a top hit. So I've put it in there. In there, it talks about something called the Dorset model, written by LABC and Dorset Fire and Rescue together. There is guidance and recommendations for thatch properties. This is snippets from my own article. If you need that reference, reach out and I can send it to you. But there are certain things that we can do. So requirements we have for thatch properties, the underside should be underdrawn with a 30-minute fire barrier. Any chimneys should terminate at least 1.8 metre above the height of the ridge. So they need to overshoot and go 1.8 metres above the line of the thatch. Chimney pots should be limited and have maximum heights. We should have smoke alarms in that thatch in the loft space, of course. Intumescent mastic is required to seal overdrawn fire barrier along all of its junctions. Again, that's a complete fire barrier, not just you overboard the rafters and then you don't make good. You've got to go into all the seals and put intumescent mastic in. And there are also some recommendations which I think are really good. Things like a loft hatch in there, 600 by 900 mil, so that fire service personnel can get up there. So if you're wearing breathing apparatus, you need the extra bit of clearance so you can get up into that space, because if you get a smouldering fire in the thatch, you need to access it from both above and below. Some guidance in there about if we've got recessed lighting in the ceilings and also rodent damage and straw debris, birds nesting in there, things like that. Some really, really good stuff. So yeah, a bit of a reference over to the Dorset model. I just slipped that in because I thought it was of relevance, and it comes up on some projects I'm looking at. I've got one at the minute, a barn conversion that's got some thatch section on the annex next to it. So yeah, Dorset model I do recommend checking out. Which I've gone over by just a minute or two, and I'll just come to the end and we'll close the session. We run these sessions every month, so thank you for attending. If you have any feedback, do please let us know. We are pretty active on LinkedIn and also on our website. So if you want to reach out to talk about this session or any other sessions we'll be running in future, do please get in touch. We are looking to promote the work of the branch. We are sharing these for free. It's a big part of our commitment to the IFE and to the industry. So we are enjoying it, but please do let us know if you are enjoying it too, or if you have a request. If you'd like to deliver a session, do let us know. Just for everyone's knowledge, next month will be a session on lightning protection, which comes up an awful lot in fire risk assessments, not so much in fire strategies, but it has come up in a strategy for one of my colleagues recently, and it took us into a bit of a rabbit hole, and we've written a webinar off the back of it. So next month's session, second Tuesday of the month probably, will be on lightning protection. Again, we'll have an early careers session and a main session, so do check that out. And there's my contact details there. That's obviously not my IFE details. If you want to reach out to me separately, joe@deltafiregy.co.uk, I'll pick that up pretty readily. And if there are questions, I'll pick them up and it'll come from that email address, because I've got to clear the room so we can get the next session on at 4. So thank you very much always to Becky for facilitating the session. Good work. Thank you to the committee and to you guys for dialing in, and we'll see you on the next one. Thanks again.
We hope this CPD material was of use to you as a member of the IFE and in providing part of your blended approach to your CPD portfolio. We welcome suggestions for sources of CPD that might benefit your fellow members, so please get in touch at the email address provided below if you would like to contribute to the range of CPD material available. To access further material, please visit our CPD hub in the My IFE portal and check regularly for new material. Finally, look out for news of our new material that might be of interest to you through our range of communication channels. Thank you, the IFE CPD Hub.